one is least cost. Second one is least cost method. Least cost method or matrix minimum method, that is known as. So WAM. WAM means Vogels approximation method or penalty method. Penalty method to find IBFS. IBFS means initial basic feasible solution to a given transportation problem. A given transportation problem. Uh, in this unit, in this unit, you will learn how to find an optimal solution to a transportation problem. So test for optimality. Test for optimality. This will use UV method or MODI method. MODI means modified distribution method. Modified distribution method. Modified distribution method. So we start the basic technique, the optimum solution for transportation problem. In the previous section, we have feasible solution IBFS. IBFS in this section to test for the optimality of the solution. We discuss the two techniques. What are the techniques? First one is the stepping stone method. Stepping stone method. Second one is the modified distribution method or modified distribution method or MODI method or UV method. Modified distribution method or UV method or MODI method. So MODI method. That first one, stepping stone solution method. Stepping stone solution method. So this method, this method is applicable in finding the optimal solution of a transportation problem. So application for stepping stone solution. Okay, stepping stone solution method. So step one. Step one. So determine an initial feasible solution IBFS. IBFS initial feasible solution by using any one of the previous methods. Step two. Step two. Check the number of occupied. The number of occupied or basic cells is equal to m plus n minus 1, and m is the number of m is the number of rows, n is the number of columns. Number of columns. Step 3. If there are less than m plus n minus 1, there exists degeneracy. There exists degeneracy, and we introduce a very small quantity belongs to as epsilon tends to 0. Epsilon tends to 0 in suitable independent cell, so that the number of occupied cells is exactly equal to m plus n minus 1. Plus n minus 1. Plus n minus 1. Step 4. Select an unoccupied cell beginning at the cell. Trace a closed path starting from the selected unoccupied cell until final returning to the same unoccupied cells. Uh, the cell at the turning points are called as stepping stones on the path. Step 5 is a step 5. Assign plus and minus. Assign plus and minus sign. Uh, Alternatively, to each corner cell of the closed path, just trace it the beginning with the plus sign at unoccupied cell uh, to be evaluated. Step 6. Uh, Calculate the opportunity cost of an unoccupied cells. Uh, this means if we shift one unit unit from a cell containing positive shipment to the unoccupied cell, that will be the net cost or net change term of cost. Step 7. Repeat repeat step 4. Repeat step 4 and 6 until the until all unoccupied unoccupied cells are evaluated. Step 8. Check the sign of each of the net change of the net change in the unit transportation cost. If all the net changes computed are greater than or equal to 0, an occupied optimal solution has been reached. Step 9. If there if there is any negative treatment to improve the corner solution and to decrease the total transportation cost, move to step 10. So select since the value of unoccupied cell are greater than a solution for the transportation problem. So example one. So what is example? A example one. So a company has factories at F1, F2, F3, which supply warehouse at W1, W2, and W3 weekly. Weekly factory capacities are 200, 160, and 90 units respectively. Weekly uh, warehouses requirements requirements are 180, 120, 150 units. So unit shipping costs are as follows. Here, here warehouses. Warehouses W1, W2, W3 means warehouses. So F1, F2, F3 are factories. So supply, demand, or availability requirement. Uh, Availability supply is 200, 160, 90. Demand is 180, 120, 150. Here, next. Here, determine the optimum distribution. Determine the optimum distribution for this company to minimize shipping costs. Solution to obtain the initial basic feasible solution by applying Vogel's approximation method. Vogel's approximation method. So to obtain warehouses W1, W2, W3 warehouses. Next, we have one the factors. So by Vogel's method, we 60 to 1, 48. Next, 26, 24, 26, or 90. No? The, the number of occupied or basic cells, number of occupied or basic cells equal to m plus n minus 1. 3 plus 3 plus minus 1 equal to 5. So there exists no degree, no degeneracy. Say to obtain the optimal solution. Uh, the stop stepping stone method. Stepping stone method is applied. The stepping stone method starts with an evaluation of each of the unoccupied is applied. The stepping stone method starts with an evaluation of each of unoccupied cells. Right? No rise. No? There exists a degeneracy. The existence there exists a no degeneracy to obtain the optimal solution. The stepping stone method is applied. The stepping stone method starts with an evaluation of each of the unoccupied cells F1 W2 F1 W2 since the requirement of the warehouse must be fully satisfied. Fully satisfied. Uh, fully satisfied. We to best warehouse W2 since the requirement of the warehouse houses must be fully satisfied. Now, we allocate the cell F1, W1 by subtracting theta units from the initial allocation of 140 units, uh, which decreases the cost by rupees 16 per unit, 16 per unit, 16 per unit, in order to make this adjustment and to satisfy the supply restriction at factories F1, F2. We subtract theta unit from cell F2 W1 and then add theta units to cell F2 W1. Here we can compute the incremental cost evolution of unoccupied cells F1 W2 as the cell. Cell I comma j F1 W2, F2 F1 W1, F2 W1, F2 W2. Here, a change in X, Xij, that is plus 1, minus 1, plus 1, minus 1. So, net change for the allocation, uh, net change for this allocation equal to plus 20 minus 16 plus 14 minus 8, 34 minus 24 equal to 10. So, 175 W1 W2 is F1 F2 minus theta 16 plus theta 20 40. Next W1 W2 W3 F1 F2 40 plus theta 60 minus theta 16 plus theta minus 16 20 40 120 14 minus theta 18. So this indicates that shift one unit into unoccupied cell W2 increases the transportation cost by rupees 10. Obviously, cell F1 W2 is not here F2 W2. We assign theta units to cell F2 W2 and by making necessary adjustment in the cells F1 W3, F1 W1, F2 W3, W1. The closed path which is associated with these changes is shown in table 4.2. The net change is cost 18 into bro. The net change in cost 18 into 1 minus 12 into 1 plus 16 into 1 minus 14 into 1. So that equal to total 8 rupees per unit. 8 rupees per unit. Since the cost is more than our initial solution, we now evaluate the remaining unoccupied cells F3 comma W1 and F3 comma W2. The path is adjusted for these net changes is shown in table 4.3. So W1, W2, W3, W2, W3, etc. 140 minus 2, W1, W2, warehouses. F1, F2, F3 are the factories. Minus theta 20, 60, 12 plus theta. So 40, 14, 120, 84, 90, 18, 16 minus theta. Uh, Here another warehouse, another table is given W1, W2, W1, W2, W3, F1, F2, F3, 140 minus theta, 40, 16 plus theta, 120, 20 minus theta, 18. 26 plus theta, 24, 60 plus theta, 12, 18, 90 minus 60. So here, the closed path and an incremental cost change for each of the unoccupied cells are given below. Unoccupied cell F1 W2 closed path F1 W2 tends to F2 W2, that is F2 W1 F1 W1. Second, F2 W3 F2 W3 F1 W3 F3 W1 F1 W1 F2 F3 W1 F13 W2 tends to F3 W3 W3 F11 F22 F11 26 plus 16 plus 12 minus 16 is in. First one is 20 minus net change in cost. Net change in cost. Change in cost. So 20 minus 18 plus 14, 16 equal to 10. 18 minus 12 plus 16 minus 14 equal to 8. 26 minus 16 plus 12 minus 16 equal to 12. 24 minus 16 plus 12 minus 16 plus 14 minus 8 equal to 10. Since none of the unoccupied cells in the above table is associated with a negative value, the total transportation cost will either remain same or increase. Hence, an optimal solution. So, optimal solution, what is there here? So, F1. So, X11, 40I, X12 0, X13 60. Similarly, factory F2, X21, X21 equal to 40, X22 equal to 120, 22 equal to 120, X23 equal to 0. So F3, F31 equal to 0, F22 equal to 0, F33, 70. So the total transportation cost 5,920. Total transportation cost. Next, most important method, modified method or modified distribution method or MODI method or UV method. Next, UV method. So, the modified distribution method provides minimum cost. Huh? Minimum cost. Minimum cost. Minimum cost to solution to the transportation. MODI method is an improvement over, over the stepping stone method. So, for MODI or UV method or modified distribution method. Step 1. Determine an initial basic feasible solution. Using any uh, one of the previous three methods. Step 2. Check the number of occupied cells. If there are less than m plus n minus 1, they register degeneracy and introduce a very small positive quantity belongs to insuitable independence quotient so that the number of occupied cells is exactly equal to m plus n minus 1. So m is the rows, n is the columns. So step 3. For each occupied cell, current solution. Uh, Solve the system of equation ui plus vi equal to cij. Starting, we are starting initially with some ui 0, vj equal to 0, and entering successively the values of ui and the vj in transportation table markings. So step 4, compute the net evolution zij minus cij equal to ui plus vj minus aj for all unoccupied basic cells and uh, enter them in the lower left corner of the corresponding cells. Step 5. Examine the sign of each Zj minus Cj if all Zj Zi తెలిస్తే ఏమంటారు మేడం ఎలా కాపురం చేస్తుందండి ఇది మాకు అర్థం కావట్లేదు. So Zij minus Cij for all if all Zj minus Ij less than or equal to 0, then cement the cement basic feasible solution is an optimum one if at least one Zj minus Cj greater than 0. Select the unoccupied cell having the uh, largest positive uh, net evolution to enter the basis. Step 6. Let the uh, unoccupied cells let the unoccupied cells R, comma S enter the basis allocation. Right. Let unoccupied cells R, comma S enter the basis allocation. An unknown quantity, say theta, to the cell R, comma S. Identify a loop that starts and ends at the cell R, comma S and connects some of the basic cells, add and subtract interchangeably theta to and from the transportation cell of the loop in such a way that the given requirement remains satisfied. So, step 7, assign a maximum value theta in such a way that the value of one basic variable becomes 0 and the other basic variables remain non-negative. The basic cells whose allocation has been reduced to 0 leave the basis. Step 8. Return to step 3. Repeat the process until an basic feasible solution has been obtained. Let us illustrate the example for finding optimal solution. Uh, optimal solution. Optimal solution of TP transporting using a UV method. Using UV method. So example given x13 equal to 50 units. X14 equal to 20 units. X21 equal to 55 units. X31 equal to 30 units. X32 equal to 35 units. And X14 equal to 20 units. Is it an optimal solution to the transportation problem? Transportation problem. First row, availability and requirement, demand and supply. Right. So 6193, no? 11, 5, 8, 10, 12, 4, 7, 70, 55, 90, huh? 2 and 5. So requirements 85, 35, huh? 50, 45, 215, 215. So balance of transportation from given problem is, if not modified to obtain a better feasible solution. So solution. So considering the given solution of an initial basic feasible solution, let us now compute the number equal to 1, 2, 3 and Vj using successively the equations. Here, Vi plus Vj equal to Cij for the occupied cells. For the choose U3 equal to 0. Thus we have U3 plus V1 equal to 3C1, that equal to V1 equal to 10. Similarly, U3 plus V3, that's 3C2, that is V2 equal to 12. Uh, U3 plus V4 equal to C34, that is plus V4 equal to 7. Given V1, V2, V4, uh, high values of U2 and U1 can be calculated as shown below. U2 plus V1 equal to 2, 2, 1. U2 equal to 1. U1 plus V4, that equal to C14, that equal to U1 equal to minus 4. Now using the value of U, we get, uh, we get, yeah, that U1 plus V4 equal to C14. And then U1 equal to minus 4. Thus, net evolutions for each of the unoccupied cells are now determined as follows. So Z11 minus C11 equal to U1 plus V1 minus C11 equal to 0. Z12 minus C12 equal to U1 plus V2 minus C12 equal to 0. Z22 minus C23 equal to U2 plus V3 minus C23, that equal to 1 to 12. Z24 minus C24, U2 plus V4 minus C24 equal to 0. Z33 minus C33, U3 plus V3 minus C33, 9. According to optimality, uh, remaining master. Since all Zij minus N Zij minus Cij greater than or equal to 0, this initial solution is not optimum. Maximum of Zij minus Cij, uh, Cij, that is Z23 minus C23, indicate maximum transportation cost. Thus, we assign units, theta units to the then we make plus theta and minus theta adjustments adjustments in the occupied cells in such a way that the requirements and availability are satisfied. satisfied. In order to maximum maintain feasible solution, feasibility, locate the occupied cells with theta assigned in the smallest allocation. Here, the occupied cells 1 comma 3, 2 comma 1, 3 comma 4 have minus theta assignments. Among these, the cell 3 comma 4 is selected. 3 comma 4 is selected because it has the smallest allocation, that is 25 units. By doing this, cell, this cell 3 comma 4 becomes unoccupied and cell 2 comma 3 is occupied in the next iteration. So cell 2 comma 3 enters the basis and cell 3 comma 4 leaves the basis as shown in table 2.4.2.4. So here, what is the table here? 0, theta, 6, 7, 1, 50, 20, minus theta, theta, here 5, 12, 2, 0, here 10, 12, 4, 7. So 10, 12, 13, 7. Here now in this addition cell, enters the basis and cell 1 comma 3, uh, has the basis as shown in table. So 12, 30, 16, 19, 25, 45, minus 12, 25, 12 minus 3, minus 12. In the iteration by computing net evolution, cell 2 comma 2 enters the basis and cell 2 comma 1. Basis enters the 1. Here, the iteration computing the evolution 2 comma 2 enters the basis and cell 2 comma 1 leaves the basis as shown in table 4.2. Similarly, in the next iteration cell 3 comma 2 enters into basis and cell 3 comma 2 have the basis as shown in table. Uh, so 25, 45, you 0 12 here minus 7, 5, 6, here 1, uh, here root plus theta minus theta, minus theta plus theta minus theta. Here loop is formed, that is minus 1, 1, minus 10, 3, 3. Okay, next one is minus 7, minus 8, 85, 6, 11, 10, minus 1, 25 plus theta, 5, 5 minus theta, 1 minus 11, 9, 50, 5, 2, 1 minus 45, minus 1, 7, minus theta, 3, 8, theta, EI, 0, 12, 0. So, uh, the final The final iteration attains optimal solution shown in table 4.28 cell Uij minus Cij less than or equal to 0. That means 0, 35, 11, minus 1, 18, 85, minus 7, 5, 12, 1, 11, 50, minus 2, 4, 2, 9, 43, minus 1, 8, 5, 7. UI is 0, 4, 4, 0, 4, 4. So the optimum solution is x1 to 30, x14 equal to 40, x22 equal to 5, x23 equal to 50, x31 equal to 85, x34 equal to 5. Hmm? So therefore, the total transportation cost is 30 into 1 plus 40 into 3 plus 5 into 5 plus 50 into 2, 85 into 10 plus 5 into 7, that equal to 1160. Okay, today what we discussed today? uh, relative stepping stone method and modified distribution. Unit 1, uh, test of optimality, degeneracy, solutions. So we discussed it today. Uh, Modified, most important method, uh, stepping stone method, and modified distribution method. In this one 10 marks question, theory question, compulsory, compulsory questions we have, students we have to learn. Understood? Uh, what is first stepping stones method algorithm? What is there? Uh, Stepping stones solution. Uh, Solution method. Uh, the modified so, the method of application in finding the optimal solution of transportation problem. Algorithm for stepping stone uh, solution method. So first step one, determine the IBPFS initial basic feasible solution using any one of the previous methods. What are the previous methods? Northwest corner method, uh, northwest corner method, and check northwest corner method, and check the number of occupied or basic cells uh, is equally to m plus n. M is the number of rows, and rows, and n is the number of columns. Number of columns. Step 3. If there are less than m plus n minus 1, there exists a degeneration. We introduce a very small, any small quantity belongs to as epsilon tends to 0 uh, in suitable independent cell, so that the number of occupied uh, cells exactly equal to m plus n minus 1. So step 4. Uh, Step 4. Select an unoccupied cell beginning at this cell. Trace a closed path starting from the selected unoccupied cells until final, returning to that same unoccupied cell. Uh, the cell at the turning points are called as stepping stones on the paths. So step 5, assign plus and minus a sign alternately to each corner cell of the closed path. So join traced beginning with the plus sign at occupied cells evaluated. Step 6. Calculate the opportunity cost of the unoccupied cells. Uh, this means if we shift one until from the cell uh, containing positive shipment to the unoccupied cell, uh, that will be the net cost or net change in terms of cost. In terms of step 7, repeat step 4 and 6 until unoccupied cells immediately. So, uh, step 8, step 9, uh, step 7. Repeat. Step 8, check the sign of each of the net change in the unit transportation cost. If all the net changes uh, computed are greater than or equal to 0 and optimization has been reached. Step 9. So if there is any negative shipment, to improve the current solution and to decrease the total transportation cost. Move to step 10. So what is step 10? Select the unoccupied cells having the most negative net cost changes and determine the maximum number of units that can be assigned to the cell. The value, the smallest value, the smallest value with the negative negative positions on the closed path indicates the number of units that can be shipped shift to the entering cell. Add this number to the uh, and add this number to the unoccupied cell and to all other cells on the path marked with a plus sign. Subtract with the number of uh, from cell on the closed path marked with a minus sign. So step 11. Since all the values unoccupied cells are greater than or equal to 0, the uh, solution retained is optimal. Okay, that is where we discussed today two methods: stepping stone method and modified UV modified distribution method or UV method. UV method. Okay, so today we discussed two methods. One method is compulsory. Okay, friends. Uh, so our unit 12 is completed. So thank you very much. I'm leaving.